So when we talk about distribution, we refer to the pattern observed in the collection of values for a variable. There is always a pattern. Those values, there's a pattern they follow. And so you would try to look at that pattern is what the concept of distribution is all about. Now, there are two different kinds of variables, two different classes of variables, and the distribution of variables in the way we're going to learn it now is related specifically to variables measured on a nominal and an interval scale, otherwise known as qualitative variable. So this particularly refers to qualitative variable, in which numerical values are assigned to phenomenon that is going on. So if you have qualitative data, I'll give you an example of qualitative data. Sex, age group, not age. Age is quantitative. Age group is qualitative. BMI categories is qualitative. Tribe, religion, these are all qualitative. You can say that BMI stage 1, 2, 3, 4. You can label it like that, where 1 means underweight, 2 means normal weight, 3 means overweight, 4 means obesity. You can label it like that. So you see, I'm saying this means that, this, that, that. But you are not really, those numbers are not really what you can do any serious mathematics with. You can't do a mean, you can do standard deviation. That's not how that variable is measured. It's measured on a nominal or an ordinal scale. So what can you do? You can do a frequency distribution. You can do a frequency distribution, and you can summarize in frequency and proportion. Frequency and proportion. So you have 4 types of distribution for qualitative data. 4 types of distribution for qualitative data. Frequency, relative frequency, cumulative frequency, cumulative relative frequency. I'll just go through them one after the other, so that if you actually do come across this kind of tables, you will understand. Isn't something to be too bothered about. Okay, so this table, I'm trying to make you understand what we just referred to on the last slide. So the table that you can see is a distribution of parity among women with ovarian cancer. So we have a set of women who had ovarian cancer. You want to know how many children they've had. Parity is number of children that somebody has conceived. So let's know what your parity, how does, so each woman that comes in, you ask about parity. And parity for these women is between 0, no child, to more than 5 children, as you have been asking. Now, you want to know what the frequency is. Now, look at that. First of all, total number. So this is frequency, which is just count. The first column, frequency, refers to count, just a count. How many women have never had a child? 15. How many women have only 1 child? 11 have had only 1 child. 11. How many have had 2? 8. How many have had 3? 6. How many have had 4? 5. How many have had more than 5? 5. Total number of women in the sample is clearly shown here as 50. So that is that. Now, when you talk about relative frequency, you are going to have to convert that whole number into a percentage. into a percentage. Of course, 50 is equal to 100%. So 50 is the entire sample. So it's equivalent to 100%. So what is 15 out of 100? Simply do 15 divided by 50 times 100. 11 divided by 50 times 100. 8 divided by 50 times 100. So you can see why it is 16. 6 divided by 50 times 100. You can see why it's 12. And so on and so forth. And by the time you add it up, it comes up to 100. So whilst frequency is you dealing with the whole numbers as they are, relative frequency is you dealing with them as a proportion. In fact, preferably as a percentage. Cumulative means adding up on top of what you already have. So to accumulate, you are collecting it and you're adding it up as you go along. So for cumulative frequency, what happens is that the frequency that you currently have plus the immediate past frequency are added together. So let me explain. Frequency of women who have had 0 child is 15. Frequency of women who have had 1 child is 11. 15 plus 11 gives you 26. 26 plus 8 gives you 38. 38 plus 6, sorry, 34 rather. 34 plus 6 gives you 40. 40 plus 5 gives you 45. 45 plus 5 gives you 50. So you can do the cumulative frequency quite easily. And then there's cumulative relative frequency. This one has to do with the percentages that you had worked out earlier. So the first one is 30, the second one is 30 plus 22, which is 52, and so on and so on. So that's what a frequency distribution table looks like. Now, how do you display a frequency distribution? You either use a table like we had just done, or you innovate and come up with a graphical form of presenting your data. A graphical form of presenting. So I'll come back here. Let's just look at different ways of presenting depending on the kind of data set you are dealing with. Okay. So we can say a bar chart. I do not need to explain what a bar chart is. The fact that you have on the x-axis, the horizontal axis is always x. You have on the x-axis different colors. You can see different colors. You can see blue, gray, green. So you have this, you have that. Then the height. So individual bars represent the different issues, the different measurements. So we want to know how many people have brown eyes, blue eyes, gray eyes, and something like that, eye color. Then the y-axis, which is the vertical axis. My cursor is going up and down there. The y-axis is supposed to be the frequency count. So the numbers as observed. So you can see that the majority is, and it's so easy, a bar chart is so easy to interpret. Very, very, very clear because it's there. It's there. It's done properly. Choose. And it's easy to understand. So it's easy for me to explain that 75, about 75, that's why I trace it somewhere about there. 75 of the study participants had brown eyes. Blue is looking like 20, of the study participants have brown eyes. No. Gray, you can see maybe like 2 or 3. And green, not at all. I think green is just one person that has that eye color. So that bar chart tells you quite a bit. It's very, very, very informative. It also hides some things, and we'll come back to look at that. This is a pie chart. So it assumes that all study participants, for example, have a variable that is categorical or even dichotomous. Sex, for example, male and female. So I ask how many males are in this class, how many females are in this class, and we use that to develop a pie chart. So a pie is just a circle covering 360 degrees, and the frequency, relative to the frequency of that particular item or that particular characteristic needs to be divided by 360 or divided by the total. So the number of, for example, if there are 150 and 100, which is 250 people in the class, just like this pie shows us, 150 of them are females and 100 are males. What does this translate to? It translates to 150 over 250. Remember, that's 2 times 100. And that will be about 60%. So when you're doing that, you have to give more space because it's not equal anymore. You have to give more space for. So you can see straight line will be 50-50. It's 60-40. And you can see your graphs should always be properly labeled. And you should always have a key. You can see I have male, female. And the frequency alongside the percentage should be displayed in the pie charts. Let's move. All right, a histogram. A histogram is a frequency. So a histogram here, you can see that histogram. Histogram measures continuous data, variables that are measured on a continuous scale, like weight, for example. And you see the frequency. Because it's continuous, you see that one bar laps perfectly with the next, and so on and so forth. Very different from the bar chart, in which you have discrete values and discrete variables that are separated. So this is another way of presenting the data. So I'll pause again and see whether we will take a few questions.